guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. I actually already did the second half and didn't realize it was recording, so I thought I would take this opportunity to be lazy. I mean, to have a video about how to interpret when there's already work and there's already a solution for problems and how to go about reading it so that you understand what they did, even though you're not seeing them work out the solution in real time. Yeah, that's what we're going to talk about. So, anyways, with number 15, that one I did by hand. A lot of the other ones I did just by typing them into the calculator. So there really isn't a whole lot that you missed other than for numbers 15 and 19. With number 15, I have arrows coming out of the 3. So a lot of times math teachers or people that can do high levels of math or whatever you want to call those people, um, weirdos, they a lot of times do their work from top to bottom, or at least they should. I mostly follow that pattern as well. So typically if you're trying to follow their work, you're working from top to bottom. Although sometimes if you see an equal sign and it wasn't already an equation, then you just follow the equal sign and you go that way. So with this problem number 15, the thing that you see at the very, very top is some arrows. I am distributing the power of 3. So the 6 gets a power of 3 and the 10 to the negative 5 gets a power of 3. When you do a power to a power, you multiply. So the 10 to the negative 5 to the power of 3 became a 10 to the negative 15. So that's what happened there. It got multiplied. It became negative 15. Right? Or if you didn't know the rule that you do a power to a power, you multiply, then you kind of just use process of elimination. Well, how do I get negative 15 from negative 5 and 3? Well, if I add them, negative 5 plus 3, that'd be negative 2. So that can't be it. Negative 5 minus 3, that'd be negative 8. I'd be adding two negatives. That can't be it either. It's not divide. I'd get a fraction or a decimal or whatever. So I'm timesing. I'm timesing 5 and 3, and that's how I'm getting 15. So if you're not sure how they got from one step to another, remember, they have to do math to get from one step to the next. I know it sounds really simple when you say it that way, but there's only so many different math things you can do, right? There's plus, minus, times, divide, powers, roots, sine, cosine. Okay, maybe there are a lot, but the basic four, plus, minus, times, divide. Start with those, and if not, maybe powers and roots. Maybe it's something else. But normally, if it's something else, then you would know because there's like some letters or some other symbols. Something. There's something. But here we're timesing to get negative 15 from negative 5 and 3. So, got that. 6 to the third power is 216. So that's where the 216 comes from. And then notice that I'm adding 2 to the negative 15, and that's also because I'm moving the decimal place over. Those arrows are not very well written there. I'm also writing with my left hand, so cut me a little slack here. But 216 became 2.16. There's some arrows showing that I'm moving the decimal place. If you're going to move the decimal place to the left, then you add 2 powers on the right hand side. So that's all happening at the same time. So if you don't know why one thing is happening, look for where something else is happening, and those two on that same line are probably tied together. So the arrows that you see for the 216 moving that over, that's there, and then on that same line is the adding 2 to the power. So those two are happening at the same time. They're countering each other so that I'm not actually changing the number. So then it becomes 2.16 times 10 to the negative 13, which means I took negative 15 and I added 2 to that number. Okay. The rest of them, you can kind of just type them into the calculator. I mean, you literally, for number 16, you just open parentheses, 6.3 times 10 squared if you have a squared button. If not, then put the like YX caret key, up arrow looking key, Y up arrow key X. Some calculators do it that way. Whatever it looks like, you probably have a squared button. Most do. But if you don't, or if you don't have another button for cubed or fourth or whatever, it's usually either the up arrow key or there's some sort of like power looking button on your calculator, depending on which one you have. If you're not sure, you're welcome to take a picture of the keys or the keyboard layout or whatever of the calculator and put it in a comment, and I'll take a look at it for you. But um, yeah, you kind of just type it in. So you literally just type in exactly how you see it for number 16. Open parentheses 6.3 times 10 squared, close parentheses to the power of -6. Enter, and mine spit out the decimal in scientific notation already. So I just wrote it out. It was in my calculator 1.6 blah 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 blah. I don't remember how many decimal places it was. And then times, and then it said E. It didn't say times. It said E, capital E, -17 is how my calculator said it. 1 point blah 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 E -17, which means times 10 to the -17 power. So that's how you interpret that result. And that's how my calculator does it. I was using a Dinosaur TI-84 Plus, not even the CE. Just I found a good deal on the calculator, so I was like, why not? And I've been using it. It's probably the most used calculator I have because I build all my programs on it as well. So, anyways, so you do the same thing with the other ones, 17 and 18. Nothing special. I just typed them in. If you need to change it to scientific notation, though, then do that. If you make the number on the left smaller, then the power of 10 needs to increase. And if you make the number on the left bigger, the power of 10 needs to decrease. That's generally the rule of thumb there. So, oh, and then also the number on the left has to be at least 1. It can be equal to 1, but it cannot be less than 1. It has to be more than 1, and it has to be less than 10. Cannot be 10, less than 10. 9.99 is fine, but 10 is no bueno, because you could just move the decimal place over one more space, and then you have a 1. So only numbers between 1 and 10. You can have 1, you cannot have 10, because they kind of conflict a little. Okay. And then I got to number 19. So number 19, I was a little bit all over the place, but kind of not, kind of a little bit. I was a little bit. But, I'm trying to fit a lot of work into a small space here. So for number 19, the very top section of the work is where I started. I did 8 divided from 3. And I did that by hand because I was like, hey, I'm going to do this by hand just in case you need to know how to do these by hand. And I did. And then I got 0.375. And then kind of like over off to the side, over yonder, right there, where's where I did the second part of my work, which was when you have a power over a power, you subtract the powers. 10 to the -2 minus a -1. You have to subtract, which means you include an extra negative. If there's already a negative sign, doesn't matter. You don't just leave it there. You keep it, but you add another negative sign in it, even if it looks weird. You just got to do it. You just got to do it. So it's not -2 minus 1. There's already a negative sign in front of the 1. It's subtracting the two numbers. -2 minus -1, which ends up being -2 plus 1. -2 plus 1 is the opposite of 2 minus 1. If you change the signs on both the numbers, you get the exact opposite thing, the opposite of the correct answer. And that's actually really, really helpful. You might think, oh, I don't want the opposite of the right answer. That's the furthest from the right answer. It's like, actually, the opposite of the right answer is like the next closest thing to the answer. Math is weird, I know. So -2 plus 1, the opposite of that is 2 minus 1, which is 1, right? So if 2 minus 1 is 1, -2 plus 1 is -1, the opposite of 1. So that's how I got 10 to the -1. And then it was, this is the third part, so I kind of jumped back over here for my third part. 0.375 times 10 to the -1. Then I had to move the decimal place over one space to the right, which means I need to subtract 1 from the power. So final answer was 3.75 times 10 to the -2. And then for the rest of them, I just typed them all into the calculator. I mean, I did. That's all I did. I done did. And yeah, so I mean, that's all there is to it. For number 20, I will say that even though I didn't show any work, you do want to put a parentheses around this unless your calculator already does the fraction bar thingy for you. You need to put the numerator and the denominator in parentheses when you're typing it into the calculator. Otherwise, it'll spit out the wrong answer. So be careful with that. Unless you have a calculator that already does the fraction bar, make sure you have parentheses around all of the numerator and parentheses around all of the denominator all the time. You don't always need it for the numerator. In this particular problem, I didn't actually need to have parentheses over the entire numerator. But I'm saying to do it because if you always remember to put the numerator and the denominator in parentheses, you won't forget to do it when you need to do it. Does that make sense? So just do it. Just do it. And then you'll get the answer right. And that's about it, actually. I mean, a lot of this was just me typing it into the calculator, converting it into scientific notation if I needed to. Let me know if you want to want me to actually work some of these problems out, either showing you like how to do it and saying what I'm typing into the calculator as I'm typing it out. That's what I originally did. Or if you want me to work it out by hand because your teacher is the spawn of Satan and they're making you do these crazy decimals off to the side. Um, I'll pray for you, and you should get another teacher. But I mean, 8.8 to the fifth power. Oh gosh, I would not want to do that. Even in my spare time as a math nerd. No, that just doesn't sound fun. 8.8 to the fifth power. Who does that to people? Child labor laws. Okay, so that's basically it, though. Like I said, I thought I was recording it, and I was not. So I am being lazy. I mean, I'm showing you how to interpret work that's already up on the board. So, anyways, if this has been helpful, obviously, like, subscribe, all that good stuff. But I also have a lot of other content, like all of the solutions to other worksheets, mainly Algebra 1 at the time of this video. But who knows, I could have a plethora of things over on my website, myersmathematics.com. So go check it out if you want to see more stuff like worksheets, videos, whole courses on stuff. I will do whatever you think will be helpful and put it on my website. It'll be awesome. And if you're watching this and it's like 5 to 10 years after the time of May 16th, 2023, then it will be awesome. Because probably take me that long before I'm able to compete with some of the bigger names, but who knows. Anyways, have a good one, and I'll see you in the next video. Have a blessed day, y'all.